All right, so we are going to use our calculator to figure out derivative and integral. So let's review again. What is a derivative? Slope of the function. Good. All right, so let's look at a curve like this. And let's say x is here, and I want to figure out the derivative at x, meaning the slope of the tangent line at x. All right, let's see if you guys remember from a while ago. What is the definition of derivative, like the actual equation? Yeah, limit. It starts with limit.
FB minus, is that the one? Oh, Fx minus FA?
Not yet. Limit as what goes to what?
S goes to...
Not x.
Y.
H. H goes to 0. Of what? F of x. The test is Friday. Just a reminder. Yeah, it's this Friday. Next week we're gonna review for finals, and then you're gonna take finals the following week, and then we're done. So basically, you gotta remember this. Yeah, A push that day. Some other person also does. They wanted to take it Thursday, so you can see if you wanted to.
Cam that day.
Yeah.
When your life's busy.
Yeah. Okay, so everyone, let's come back. Let's finish this formula. Good. Over. Okay, this is the definition of derivative, which says if you want to figure out the slope of the tangent line, remember the tangent line at x, then it's kind of bad, like this. Then you can't really, because you don't have 2 points to create this line, so then you just need to find another point that is x plus h, so that you can draw a secant line, and then eventually you move it so much closer. This part is h. You move it so much closer to x, where h is almost 0, and then you have this tangent line slope. Okay? You guys with me on that? We're changing from a secant line to a tangent line. Now, on the calculator doesn't really calculate it this way. They are not bringing 1 point over to where x is. They actually have 2 points on two sides of x, and they were bringing both to x. Okay. So they have 1 point that is x plus h away, and they have another point that's x minus h away. And then what they're doing is they are going to do limit as h goes to 0. But basically, instead of 1 point coming in, both points are going to come in towards x. Okay, so this is going to be the limit as h goes to 0 of f of x plus h minus f of x minus h all over 2h, because you're 2h away from x now. All right, so this is the definition of derivative, which means the derivative of the function at any x. And if you want the definition of derivative at a, it's going to be exactly the same thing, except you're going to change all of the x's into a. And then same thing as for the one that's on the calculator. All right, let's use our calculator. So we are going to find, so f of x is equal to x cubed. Okay, this makes no sense. We want to find the derivative at 2. So we want the derivative at 2. Most of you have the TI-83 you're going to follow the TI-83 direction. If you have inspire, then you're going to follow the inspire direction to figure out the answer. So we have the function x cubed, and we want to figure out the derivative at 2. So you're going to click math button. Do you have a calculator? Oh, just take it. So you want to click the math button. Oh, okay. If you have 83, so that's the old one, you're going to follow that instruction over there. It's the old one, so you have to actually type it in. It's a little different. Okay, so type it in, and then you want to figure out what is f prime of 2. What's the derivative at 2? Go ahead and try it.
What are we supposed to put in the x?
X is equal to 2.
Like 2 in every x?
Hmm?
I got that.
Oh, no. In that, here. Like that. You put x cubed. The function is x cubed. So you are taking the derivative of what function? X cubed. All right, your calculator is going to say the derivative at 2 is 12.000001, something like that. The reason why it's actually just 12. Why is there such an approximation? Because what your calculator is doing is kind of bringing 2 parts in, and then so there's some error in the way it's calculating, but the answer is actually just 12. There's no dot 0.000001. Okay. Yeah, so sometimes your calculator is just trying to approximate. So sometimes you will see something like e negative 30. That just means 0. You just cannot approximate that well. All right, let's do some calculator practice. Okay, find the derivative of the following at specific points. From this moment on in calculus, you are never going to use degrees anymore, so always keep your calculator in radian. Okay, so when you get this cosine 2x, you got to make sure your calculator is in radian, especially since that is pi over 2. You got to be in radian. All right, let me know when you have the answer to 1, 2, 3. Okay, so the answer is 20, 0, and 0.276. Okay, and then also from this point on, please get used to rounding to 3 decimal places. Okay, at least 3, okay? All right, next, that was derivative. Now let's go ahead and do integral. What does integral mean? It is the area under the curve. Good.
Genius.
Area under the curve. All right, so what's going to happen is you have this curve, and let's say you want the integral from a to b, meaning what is the area under the curve from a to b? Okay, now we couldn't really find a good way to do this. We had to use Riemann's sum, where we drew a lot of rectangles. But your calculator can draw infinitely many rectangles, and then so basically it can create a smooth curve. So integral by calculus, we do an integral sign from a to b of f of x dx. Again, f of x means the height, dx means the length of the base. And we write dx because there's just infinitely many rectangles, and eventually becomes a smooth curve. Integral by calculus, calculator, it is using the Riemann sum. There's just infinitely many, so limit as n goes to infinity. All right, so now how do you actually do this on the calculator? Your calculator is really, really, really fancy. The way you use it, when you click the integral button, it looks just like the integral sign, so it should be pretty intuitive figuring out what goes where. So let's see. First, this one. Try to figure out the area between 1 over x and the x-axis. Okay, so 1 over x and the x-axis from 1 to 4. So what's the area between x 1 over x and the x-axis between 1 to 4. Okay, if you're using 83 or 84, you're gonna go to the math button, and then there's a FNINT, meaning the integral function integral, and the TI-84 is very intuitive. It looks just like an integral sign. Okay, so what goes inside the integral sign?
1 and 4.
Inside. What's the function?
1 over x.
Okay, good. 1 over x, and then it has a d something, right? D what?
Yeah.
dx, good. dx. And then from where to where?
1 to 4.
1 to 4. Okay, if you just type that in, it will give you the correct answer. And then if you have the inspire, you follow the inspire directions.
Why is it giving alpha for the
Why do you give a negative?
Give you alpha?
It's like automatically going to alpha.
The answer is 1.3863.
Let's go.
All right, good. Now let's, yeah.
How many?
At least 3, so 1.386 is the official answer.
Wow.
Just 3 every time.
Just 3.
I like William's scoring a lot better. Well, no.
Oh, the graphing thing?
Yeah.
Oh, yeah, that's good too.
It's more basic.
Yeah, but sometimes you don't have time to type, all that in. So it's up to you whichever way you want. Okay. Yeah, it's up to you. Yeah, that way is also very good. All right, let's have you practice. Again, please keep your calculator in radian mode. Okay, number 1 is 8. Number 2 is 1089.244. Number 3 is 50.667. All right, now let's look at word problems. So the AP calculus is all word problems. There's almost not much of simple stuff. It's just, do you understand what you're doing? So let's start looking at the kind of questions that you may experience next year. Okay, so for example, this first one says, an automobile is driven at a variable rate along a test track for 2 hours, so that its velocity at any given time, any time from 0 to 2 hours is given by v of t equals this thing, miles per hour. How far does the automobile travel in the 2-hour test? All right, let's look at this. We have time, and then in the y-axis, we have velocity. So there's some kind of curve. I'm just going to randomly draw a curve, something like that. They want to figure out how far you travel from 0 to 2 hours. From 0 to 2 hours. So the big question is, are you looking for derivative or are you looking for integral? Because that will, basically determine whether you got the answer right or not. So distance, is that the derivative of velocity or is that the integral of velocity? All right, I probably should give you a hint. All right, so there is a relationship between all this. Okay, so you start with position. If you take the derivative, it becomes velocity. If you take the derivative, it becomes acceleration. Okay, so this direction is derivative. So distance, when you take the derivative, you're dividing by time. So distance over time is velocity. Okay, how far you went over how long it took, that's velocity. How fast you took and how long it took for you to go to that speed is acceleration. Okay, so if you take velocity and divide by time, it becomes acceleration. If you go backwards, acceleration goes back to velocity and then goes back to position. That's called integral. So derivative goes forward, divide by time, divide by time, divide by time. Integral goes backwards, multiply by time, multiply by time, multiply by time. So that's the relationship between derivative and integral. Derivative goes forward, integral goes back. It's okay. Next year it will, be drilled into you. So this question, We are given velocity. We want to figure out distance. Okay, we're given velocity. We want to find distance. Talk to your partner. Are we looking for integral or derivative? We are given velocity. We want to find distance. Which direction do we want to go? We are given velocity. We want to find distance. So that's integral or derivative? Integral. We want integral. Okay, we want integral. So we want the integral of velocity from where to where? 0 to 2. All right, so then you just plug that into your calculator. Why do you want integral? Because they tell you how fast you're going. They tell you how long it took. The question is, what distance did you travel? Okay, so the integral from 0 to 2 of v of t is going to give you the distance this car traveled in 2 hours. So that is 60.26, what did you guys get? 261? 260 miles.
Wait, what did you put into the...
So v of t is this function, so you had to put this function in the calculator.
Oh.
All right, let's try another one. People back there, focus. All right, Bob leaves for a trip at 3 p.m. 3 p.m., we're going to say time is t equals 0. And then he's going to drive with velocity v of t and then whatever that is, where t is measured in hours. Find this. Integral from 0 to 2 of this thing. What is this thing? 60 miles, one half t. 60 miles, 1/2 t. The function of what? Velocity, right? It tells you that's velocity. So integral of a velocity is going to give you what? Position, very good. So, or distance travel, right? So from 0 to 2 means what?
Hours.
2 hours, right? So this is asking, how much did Bob travel in 2 hours? How far did he travel in 2 hours?
Oh, okay.
How far did he travel in 2 hours? So go ahead and figure out the answer using your calculator. Okay, so the answer is 119 miles.
That's right.
Now, what does this integral mean?
How far you drive?
How much he drives in 2 hours. Now, let's talk about time. He left at 3 p.m., so what does that mean?
At 5 p.m.
Yes. Yeah, at 5 p.m., he traveled 119 miles. Okay, so at 5 p.m.
That's kind of fast.
Yeah.
No.
No,
Okay.
you're going 60 miles per hour.
No, 60 minus 1/2 t.
All right. Okay, the last thing we're going to do is we're going to use the table function on your calculator, and we're going to input some data. All right. Oh, Robin, can you keep all your comments to yourself? Okay. So the table shown on the left shows the height in feet of a falling ball above ground level as measured by motion detector at time interval of 0.04 seconds. Okay, so basically you drop this ball, and then at every 0.04 seconds it's recording where it is relative to time. Estimate the instantaneous speed of the ball at t equals 0.2 seconds. Okay, we want to figure out how fast this ball is falling at 0.2 seconds. There's not a lot of information except for this table. Okay, so what we're going to do is we have to graph these points and then use the calculator to figure out what function that is. All right, here we go. All right, so how you actually put in, I think in chemistry you probably tried putting this in. All right, so what you're going to do is you're going to go to the stat button. Okay, you're going to go to stat button, and then you're going to go to edit. Stat, and then edit. And then now you have a L1 and L2 and L3 and so on. So in L1, let's put in time. And then L2, let's put in position.
How do we type it times?
You don't have to type in anything. I'm just saying put all your numbers that's from there in. So this list goes in L1 and this list goes in L2. Okay, so if you want to go to the next row, just press enter. Make sure all the numbers are correct, because if you mess up on one point, then your graph will be wrong. All right, the next thing you're going to do is you're going to graph it to see what data, what shape did you actually enter with all this data. So what you're going to do is, this is a stat plot because you're actually putting in points. So you're going to go and turn on the stat plot. So you're going to go second, and then y equals. So instead of going to the function, you go to the one above, which is stat plot. We're going to turn it on. So turn on the first stat plot. You're going to see stat plot 1, stat plot 2, and right now it's off. So you're going to go to the on button and then press enter, and that would turn it on, meaning like it's going to highlight in black or whatever color yours is.
Wait, how do we turn it on?
Use Okay, now you are going to graph it. To graph it, you have to choose a specific zoom. So you go to the zoom, and then one of them says zoom stat, which should be number 9. It says zoom stat. Okay, zoom stat. It should give you a curve with like points.
I have points and a line.
That line is because you have something graphed before. You can just erase your graph.
What does the arrow mean?
I have a
That might mean that your lists are not, like you have one less number somewhere. You might want to double check.
Where do I double check?
Go back to your list and see if both of them have the same amount.
Yeah, they do.
Then you shouldn't have an error.
I have nothing.
You have to go zoom 9. Are you sure? Did you turn on your stat plot?
with trays.
Okay, so now if you look at that graph, what kind of shape does it look like? A curve, right? So probably not exactly linear. So we're going to use quadratic to guess. So you're going to go to stat again, and then this time you're going to tell your calculator to estimate an equation. You're going to go calc, so calculate. And we're going to guess that it's quadratic. So number 5 says quadratic regression. Okay, and then if you have the 84 calculator, it will automatically choose L1 and L2 as X and Y. If you don't have that calculator, then you have to type in L1, comma L2. But it should automatically pick for you. Enter. Okay, remember your graph is going to be ax squared plus bx plus c. So then a is whatever that number is, b is whatever that number is, c is whatever that number is. Okay, so that creates an equation. Next, we're going to use that equation to figure out what it's doing at 0.2. Finally, we now have an equation. We have to estimate the derivative at 0.2. So you got to write down all your A, B, C into that equation. Use your calculator to find the derivative at 0.2.
Oh, we put the entire equation in?
Yes.
Oh my.